This is AQA GCSE Chemistry. It's a triple only topic, so dual award scientists will not need to consider this particular section or this video. We're going to take a look at titration calculations. So I'm going to recommend you pause as you go, have a go at these activities for yourself and see how you do. To begin with, we're going to remind ourselves of some of the mole calculation triangles or equations. So see what you can do with those. And hopefully you can remember that number of moles is mass divided by molecular mass, and number of moles is concentration multiplied by volume. They are both going to be incredibly important as we go through the remainder of the chemical calculations topic. Moving on to some more specific questions here, we're going to take a look at the fact that we have got 40 grams of NaOH. We're dissolving it in water to make up exactly 1 decimeter cubed of solution. What would its concentration be in grams per decimeter cubed? And hopefully that's nice and straightforward. I've got 40 grams in 1 decimeter cubed. That's 40 grams per decimeter cubed. But we can use the periodic table, try and find out the relative formula mass of sodium hydroxide. And again, if we take a look at this, sodium is 23, oxygen mass number of 16, hydrogen mass number of 1. Add those together and it has a relative formula mass of 40. So if we now know the mass of NaOH and the relative formula mass of sodium hydroxide, how many moles did we dissolve? And we can see that we had 40 grams with an MR of 40. So we dissolved 1 mole of sodium hydroxide. So what would the concentration therefore be in moles per decimeter cubed rather than grams per decimeter cubed? Well, we've just established that there is 1 mole and we dissolved it in 1 decimeter cubed. Concentration is number of moles divided by volume. That's 1 over 1. So 40 grams per decimeter cubed sodium hydroxide is 1 mole per decimeter cubed. Got some examples here of calculations that you might need to carry out. Going to let you have a read through. And then we are going to take a look at some calculations for you to actually try. So have a go at each of these, and then when you've tried, unpause and we will review. So on number 1, what mass of potassium hydroxide is there in 50 centimeter cubed of a 0.5 molar solution? We're going to need N is M over MR and N equals CV. We're going to start with number of moles is concentration times volume, 0.5 mole dm to the minus 3, and I'm converting my 50 cm cubed to decimeters cubed. I multiply those together and I see that I had 0.025 moles of potassium hydroxide. I now know the moles and I can find its MR. The MR is 56. Multiply those together and I find my mass. It's 1.4 grams. Let's have a go at the next one. Exactly the same format. Number of moles is concentration times volume. I've converted my volume into decimeters cubed. I get 0.001 moles. I then find the MR of sodium chloride, 58.5. Multiply that by the number of moles. I find my mass. It comes to 0.0585 grams. And let's have a look at the final one. So on here, my number of moles is concentration times volume. That's 0.2 times 500 over 1,000. I've got 0.1 moles of lithium chloride. I multiply that by its MR, 42.5. I have a mass of 4.25 grams. So what we're going to do to take us through the remainder of this video is look at titration calculations themselves. And this will look quite familiar. The table is very similar to what's used in reacting masses calculations. The only difference is that instead of M, MR, N and ratio, we have concentration, volume, N and mole ratio. But I'm going to go through step by step and then let you have a go at doing so. So we have got a volume and concentration of sodium hydroxide. We've got a volume of hydrochloric acid and we want to know the concentration of hydrochloric acid. You start off by drawing out this table. This never ever changes. You then put the species in that you want to know about and the one that you have the information about. And then you can start to put in everything that the question tells you. So we were given our 2 volumes, I've converted them to decimeters cubed, and we were given the concentration of HCl. What I can now see is I've got C and I've got V for HCl, so I can calculate the number of moles. I can then use my mole ratio, 1:1 mole ratio, which means 0.005 moles. And then from there, I can see that I can work out 0.25 moles of NaOH. So let's have a go at some examples. Try this and unpause when you're ready. So I'm going to start by drawing the table. I've got my HCl and my NaOH. I was given the concentration of NaOH and my volume of HCl and NaOH. I can now calculate my number of moles of NaOH, and I can use my mole ratio, it's 1:1, to see that I've got 0.005 moles of HCl. I'm now going to calculate my C. N is C times V, so C is N over V. I get 0.25 moles per decimeter cubed. Another example for you to try. And again, I'm going to draw the table out. That never ever changes. I put in all of the data that's been provided in the question, and I then work out what I can work out. I can get my moles of NaOH. I have a mole ratio from the equation of 1:1. So I also now have my moles of HCl, and I can do my final calculation to find C, and that comes out this time as 0.21 mole dm to the minus 3. Next question. And we're seeing a very familiar pattern here. So the table gets drawn out, the data all goes in that's been provided. I can calculate my moles of NaOH. My mole ratio is 1:1 again, so I have my moles of HCl, and from there I can work out C using N and V. It comes to 0.25 moles per decimeter cubed. And the final question, same table. Data that has been provided goes in, 0.5 mole dm to the minus 3, my 2 volumes. I work out my moles of NaOH. Using my mole ratio, I now know how many moles of HCl there were, and then I do my final calculation to find C. My concentration of HCl is 0.42 mole dm to the minus 3. That takes us to the end of this video. Thank you for listening, and goodbye.